In today's video, we are looking at a calculus question. In particular, we'll be doing cubic functions. November 2021, question 10. So let's look at the question. Given the graph of h of x, which is equal to ax to the power 3 plus bx squared is drawn. Then we're given the coordinates O is 0, 0, then B, which is the turning point, that is 4 and 32, and A is the x-intercept. The first question, show that A equal to negative 1 and B is equal to 6. So what we're going to do here, question number 10.1. We are given h of x is equal to ax to the power 3 plus bx squared. So basically we are trying to solve for a and for b. And then we look at what is given. We are given a turning point or a stationary point. So what we're going to do, we're going to create two equations. One equation, we will make the first derivative equal to 0, then we substitute 4. Then the second equation will substitute this point into the original equation. Then we solve for A and B. So let us start. So let's start with the first equation. So we'll make a derivative of this equal to 0. So h prime x is equal to, this will become 3a x to the power 2 plus 2b x. Then we make this equal to 0. Then this is 3a. Then we take this x, that is 4 to the power 2 plus 2b, x is 4. And then we have 0 equal to 4 squared is 16 times 3, that is 48a. 48a, and then plus 8b. Now, because 8 is common, I can just divide by 8 to simplify it a bit. Then you get 0 equal to 48 divided by 8. That will give us 6a plus b. And then you simplify this a bit. You get b is equal to negative 6a. So that's our first equation. Our second equation, we're just going to substitute the point into the original equation. So that will give us 32 is equal to ax is what? It's 4 to the power 3 plus b 4 to the power 2. So we have 32 is equal to 4 to the power 3 is 64. So that is 64a plus, that will be 16b. Simplify it a bit, divide by 16, and then that will be 2 is equal to 64 divided by 16, that is 4a plus b. So that's equation 2. Now I'm going to substitute equation 1 into equation 2. We know that b is equal to negative 6a. So we'll have 2 is equal to 4a minus 6a. So 2 is equal to 4a minus 6a, that is negative 2a. And then you divide by negative 2, and then you have a is equal to negative 1. And then to get b, let's substitute negative 1. So it's negative 6 times negative 1, which is equal to positive 6. So we got what they wanted us to prove. So our equation is h of x is equal to negative x to the power 3 plus 6x squared. We move on to the next question. The question is determine the coordinates of A. And we know that A is the x-intercept. So we make y equal to 0. So we have our equation. So it's 0. 0 is equal to negative x to the power 3 plus 6x squared. Transpose everything to the left. X to the power 3 minus 6x squared is equal to 0. Then x squared is a common factor. You are left with x minus 6 equal to 0. Therefore, x equal to 0 or x equal to 6. The coordinates of A will be 6 and 0. So that will be 6, 0. Then we move on to the next question. Write down the values of x for which h is increasing. So where is h increasing? From this turning point up until we get to 4. So 10.3, that is question number 1, that's 10.3.1. So x is element of, remember this is 0, 0. Where is this function increasing? It increasing in this interval from 0 up to 4. So it increasing when x is 0 up to 4. Question 10.3.2. They're asking for the values of x for which the function is concave down. So where is this concave down? We know that this is concave up until you get to this point of inflection. Now from this point of inflection up to infinity is going to concave down, meaning that we'll have to work out the point of inflection. So the first derivative, let me work it out here, 10.3.2. First derivative of this is going to be negative 3x squared plus 12x. Then second derivative is going to be minus 6x plus 12. Then you make that equal to 0. Then you have negative 6x plus 12. Then you transpose the 6x. You have 6x is equal to 2. So we divide by 6, x is equal to 2. So we know that this is the point of inflection, that is 2. So the function will be concave down from 2 all the way to infinity. So we can just write the solution as x greater than 2, or you write x element of 2 to infinity. Now we do the last question. Question number 10.4. For which values of k will this function negative x minus 3 to the power 3 plus 6x minus 1 to the power 2 minus k equal to 0 have one negative and two positive, two distinct positive roots. So what I'm going to do here, I'm just going to write this as minus x minus 1 to the power 3 plus 6x minus 1 to the power 2 is equal to k. So basically, if you compare this with the given function, which we worked it out to be x to the power negative x to the power 3 plus 6x squared, basically it means that you just take this function and move it 1 unit to the right. So if I can quickly trace this function and move it 1 unit to the right, you will get something like this. So this is what we get. That green graph is that graph that has been moved 1 unit to the right. So what we have here, this x-intercept now, instead of being 6 and 0, is going to be 7 and 0. Then the y-intercept, instead of being 1 and being 0 and 0, now it's going to be, we're just going to substitute x to be 0 here, and then you'll get 7. So this is going to be 0, this point is going to be 0 and 7. Okay. Now what you want to do here, You want this new graph that has been shifted 1 unit to the right, this equal to k, to have one negative root and two distinct positive roots. So we know that the value of f of x equal to k, that's a horizontal line. So I'm going to draw that line. I'm going to do it in blue. Okay, so that's the horizontal line, f of x equal to k. At the moment that f of x equal to k, intersect this graph at 1 point. So that is not what we want. We want this line to intersect the graph at 3 points. And one of those points must be negative. The other two must be positive. So I'll just move this line up. At the moment now it's intersecting the graph at 2 points. Then we move it up again. Now we are intersecting at 3 points. But this, that, and that are all positive. We don't want that. We want one of them to be negative. So we move it up again. Now from this y-intercept, which is 0 and 7, as you move up from that, you can see now that we got what we wanted. So we are intersecting at 3 points. So that is 1, 2, 3. And 1, 2 are positive, and that one is negative. So from 7, which is the y-intercept, from here, 7, which is the y-intercept, all the way up until you get to this turning point, which y is 32. You can see that this graph, this line, this blue line, will intersect the green graph at 3 points, where 2 of them are positive and 1 is negative. So our solution K must be between 7 and 32. So from 7 to 32, we get the solution. So you're going to write K, you see that you write K element of 7, 32. Or you can just write 7 less than K less than 32. So that's the end of that question, and that's the end of the video, and thanks for watching.